For the full range of the research that's being conducted there, this is very big.
It's something that you know is going to benefit generations that come after me.
A forester is a steward, and most people that get into forestry are concerned about long-term sustainability of the forest.
We need forests for paper, for lumber, for all sorts of things. So the question is, how do we get that resource and those commodities, and yet at the same time have something out here in the land that people see, number one, is healthy, number two, is sustainable, number three, is a friendly place to go for recreation.
I guess we were standing in a dinner line at some sustainable forest management function, and we were approached by one of the people in the forest industry. His name is Frank Oberle, and he said, how would you guys like to structure an experiment to look at sustainability? And boy, what a gift. Never in my wildest dreams would I have guessed that we'd be involved in something like this.
A lot of the research that was initiated up to that point was fairly small scale research, a few plots here, a few plots there. We decided that we wanted a study that was more site level, cut block level, landscape level.
EMEND is an acronym that stands for Ecosystem-Based Management Emulating Natural Disturbance. It's an experiment that we've set up here northwest of Peace River to actually look at how natural disturbance and human disturbance affects our forest systems and how they recover after that disturbance, and what kinds of ways we could take that information and use it innovatively to make forest management better.
In the old days, we of course went out and took all the trees off, clear cutting, and of course we got a pretty bad name for the look of our clear cuts and the amount of material we were removing, so that when we realized that we needed to have some retention on the landscape to support habitat for the little critters, and we didn't know what level to do, what level to leave. And of course every time we leave something on the forest, it actually increases our cost.
Albertans value many things from their forests. We value the economic outputs from forests, such as timber and pulp. We also value the biodiversity, the wildlife that come from the forests, and we also value them as a playground area to recreate in.
I don't see this as something new. It's not something that we've invented. I think it's kind of the evolution of forestry.
Well, this experiment is supposed to go for a full rotation. That means somewhere between 90 and 100 years. Obviously, I won't make it all the way to the end, but we're trying to understand how forests develop, evolve, change, how their components interface with each other and interact.
All of this knowledge is out there. We step on it every day, right? But we don't understand very often what we're stepping on until we get on our knees and we get down and we see what's going on. EMEND represents that.
I would hope that the work that we're doing today in terms of trying to create forests of the future that are intact ecologically and can provide for a wide range of values, that they'll continue to be there for our children and our children's children in the future. And I would hope that forest managers way in the future will look back on the people who set up and initiated the EMEND experiment and say, I'm glad they had the foresight to make that investment, because it's sure providing for the things we need to know today.
We were involved in the logging plans initially with EMEND, helping to set up the structure of which blocks would be logged and at what level of retention. And then we helped to implement that, and then we stayed involved through funding to ensure that the research was on it to look for the beetles, gastropods, and all the other critters that are being monitored out at EMEND.
Instead of seeing a clear cut, which is, doesn't have any trees sticking up at all, what you'll see now is clumps of trees that are left behind. So instead of having all that wood removed from the area, you have some green trees, you have some dying trees, you have some dead trees, and you get a lot of the legacy elements, if you will, that you find in a natural forest, especially one that's being burnt.
And our feeling is that the research that's being conducted at EMEND has great value in that we are then able to support our management decisions with real data.
We have 600 plots spread throughout the EMEND site, so 6 in each of our blocks. And on those 6 plots, we measure everything from understory vegetation, down courseway debris, standing deadwood, live tree mensuration data, all the epigeics, arthropods.
One of the main questions that we were looking at is what size do these patches need to be to preserve biodiversity? Just to interject here, this is a pitfall trap. This is the system that I use to collect my samples, and we can see it in the ground here. Essentially, you just dig a soil core out, you sink a large yogurt container in and a small yogurt container inside, put some fluids in, and the beetles walking along the forest floor fall in these, and we come along and collect them throughout the summer and take them back to the lab and identify them.
Behind me here on the hill is a 10% retention slash burn. This is where, a couple of years after we did the original treatments and the burns weren't really happening, we thinned out to about 10% retention, split the block in half, and then burnt one side.
And what I can say here is that my own personal goal has been to actually have students come out of their association with this project ready to go forward into a world better prepared than I ever was.
It's not easy to walk in, but you can even just see here over by Vanessa just how dense some of the stuff is coming in for spruce regeneration. So it all seeded back in really quickly.
We're starting to see some fairly good results, trends, and how well the species are recovering in different percentages of retention levels. So that's going to help us make some decisions of what level of retention is optimal for our logging in the boreal forest.
It is a long-term study, but even before we put the study in place, I was learning things. This is all about learning, and learning doesn't occur at the end. It occurs during the journey.
It's really about working together and recognizing the synergy that can happen when you've got researchers working with industry and understanding what we do, and then based on the results that they get, determine where we need to make some adjustments so we can hit the target a little bit quicker.
Our industry partners have very definitely been partners right from the beginning. DMI and Canfor were in this from the start, and they've been enormously helpful, not only just in terms of putting up some of the funding that was required to make this happen, but also in terms of being engaged and involved, being receptor organizations that told us when they tried things, if they didn't work, what more they needed to know. So, I mean, that's been a wonderful, wonderful piece of the whole puzzle.
We wanted to be able to carry this thing on for a full rotation, and that's 80, 100 years. And because a lot of the answers won't appear until we've gone through a full growth of a forest.
This is a change in philosophy on how forests should be managed. This is about getting at what the right answers are and implementing those.
Once people go to EMEND, they have the essence or the sense of what it is, and they want to be part of it.
I think one of the great ideas that I just brought with this visit is that I realized that the academic staff or the academic interest are linking with the forest and the industry forest, and that and also with the politics or the people that drive the policies of management forest here, and that's a huge importance for me.
There's a lot of discussion now how to actually conduct forestry in an environmentally friendly way, and these are the kind of things that are discussed a lot of the time in Sweden, to do similar things, but we really haven't got to the point that we have large-scale experiments of this type.
You know, one of the things that I think has really changed in the time of this experiment is we've gone from an idea of emulating natural disturbances to being inspired by natural disturbances.
Even though EMEND is a very long-term experiment, which we hope will last for 100 years, the benefits of EMEND are already being seen today.
We've been able to show that by sitting down on a stump and understanding how these systems function, we've been able to design new management systems that are more effective ecologically and economically, which is great.
Things like this are just have so much value for guiding forest management.
You know, the world is a very complex and interesting place, and it's just fascinating. There's so many things we can learn about it and so much that we can do with what we learn.
That, to me, is what EMEND offers. It's hope.